Hi and good morning. My name is Alif Amruddin Business One and from SEG program. Today I will present about the Boyle's law experiment. This is a experiment. This is about volume and pressure. So other than volume and pressure will make it a constant as a constant. In this virtual lab, the whole constant it will be placed up here. We can constant volume, temperature, pressure for volume, pressure for temperature. The width that we will control a stopwatch, but we will not use it. This collision counter is for the amount of collision that we make by particle to wall of the container. How much at the time period, but we don't use it. This is a particle. There are two types of particle: heavy particle and light particle. Heavy particle is a large particle also. Light particle is small particle. So today we'll do about a Boyle's law experiment. So in a Boyle's law experiment, the temperature is a constant, but we cannot click it yet. Thus, we but before that, for this experiment, we will use a 5.0 nanometer for the container first. Then we insert a 50 particle light particle first. Then we can click the temperature. So we can do a constant temperature. From this, we can know the pressure to get the value, the exact, not the exact value, the steady pressure we need to pass and get the value. So we record the value of pressure that be exerted. So we continue for the next is 10 nanometer for the container. Then we unpause. Then we can get it the pressure. So we pause it again. So the value is 5.4 atm. We record it in our table. Then for the last one, we will do for 50 nanometer for the container. So we play it again and pause to record the pressure in the our table. So for the second one, we'll use a heavy particle. So we insert 50 heavy particle and we play. Then when we play, we must hold constant for the temperature so we can get the pressure. So the pressure we must pause to get the exact value. So from this is 11.9. So we go to the next one is 10 nanometer, 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 and we click play again. Then we will record the pressure value for 50 particle at 10 nanometer container. So the last one is 50 nanometer. So we keep play again. Then we click pause and get the value for the pressure for the last one. From the what we observe, when the particle is being exerted in the small container, the pressure is very high. But when the be drag and continue to large, the pressure is become smaller. This is because when the volume increase, the particle will collide less frequent to the wall of the container. So less collisions mean less force. The less force result in a low pressure in the container. So in conclusion, it shows that pressure is inversely proportional to the volume. That's all. Thank you.